Hello friends, welcome back to my channel Path of Physics. In this video, we are going to discuss about black body and some terms related to it. So what is black body? A black body is an idealized physical body that absorbs all incident electromagnetic radiation regardless of frequency or angle of incidence. The name black body is given because it absorbs radiation of all colors of light. When the black body is heated, it emits radiation and is called black body radiation. When the black body is heated, it reaches certain temperature and it emits radiation. So, what is black body? A black body is basically a body which absorbs all kinds of radiation. Simply, we can, in simple terms, we can tell like that. Now, the radiation is emitted according to Planck's law. The blackbody spectrum is determined by temperature alone, not by body's shape or composition. Now, remember one thing, the radiation emitted by stars and planets are similar to, can be called as blackbody radiation. They are not perfect black bodies, but they can be called, the radiation emitted can be called as blackbody radiation. And some examples of black body are stars are best examples. So stars and planets are natural examples of black body. Then Ferris black body is there. Vienn's black body is there. So these are some of the examples. The black body spectrum is determined by temperature alone, not by body's shape or composition. Next, an ideal black body in thermal equilibrium has two main properties. Thermal equilibrium means here the black body will be at constant temperature. Heat entering the black body will be equal to the heat escaping from the black body. So an ideal black body will have two properties. It's an ideal emitter, means it emits all kinds of radiations. Then it is a diffuse emitter measured per unit area perpendicular to the direction. The energy is radiated isotropically independent of direction. Means in simple terms, it emits all kinds of radiations equally in every direction. Now next we have to learn some terms. Emissive power. The total emissive power of a body is the total amount of energy radiated per second per unit area at a given temperature. It is denoted by capital E. Its SI unit is joule second inverse per meter square or watt per meter square. The ratio of total emissive power of a body E to the total emissive power of a black body EB at same temperature is called emissivity or relative emittance. It is denoted by small e. Now, small e, relative emittance or emissivity is equal to emissive power of the body divided by emissive power of a black body. It can be written as emissive power of the body E is equal to emissivity small e times emissive power EB of the black body. Emissive power of black body EB. Now for a perfect black body, emissivity is equal to 1. Now for other bodies, emissivity is less than 1. There are bodies that are not perfect black bodies but can be called as black bodies. They are similar to black bodies. These bodies have emissivity less than 1. Now next is absorptive power. The total absorptive power of a body is defined as the ratio of the quantity of energy absorbed per unit area per unit time to the total energy falling normally upon it in the same time. It is denoted by small a. Now an analysis on absorptive power and emissive power shows that good emitters are good absorbers also, while bad emitters are bad absorbers. Now next is reflecting power. The reflecting power of a surface is defined as the ratio between the quantity of energy reflected per unit area per unit time to the total quantity of energy incident on it in same time. It is denoted by small r. Now next is transmitting power. Transmitting power of a surface is the ratio of quantity of energy transmitted per unit area per unit time to the total energy incident on it on same time. It is denoted by small t. Now next we have to learn about the relation between absorptive, reflecting and transmitting power. Consider a body. Let I be the incident energy per second per unit area falling on the substance. Now, some of the incident energy may be absorbed by the body, some of it will be transmitted, and some of it will be reflected. Let capital A, capital R, and capital T be the portions absorbed, reflected, and transmitted respectively. So, summing this capital A, capital R, and capital T will give you I. A plus R plus T is equal to I. Now, capital A can be written as small a times I. What is small a? Small a is absorptive power. So the absorbed energy is equal to absorptive power times I. Incident energy per second per unit area of the substance. Now R is the reflected energy per second per unit area of the substance. It is equal to reflecting power times I. Now T is the transmitted energy. T is equal to transmitting power times I. Now substituting these three equations in the above equation, we get AI plus RI plus TI equals 1. Now cancelling I, we get A plus R plus T is equal to 1. That is absorptive power plus reflecting power plus transmitting power of that body will be equal to 1. Now from this equation we can infer some ideas. For a perfect absorber, absorptive power will be equal to 1. Reflecting and transmitting power will be 0. It appears to be black. That body appears to be black, thus it is called a black body. For a good absorber, absorptive power will tend to 1. Reflecting and transmitting power will tend to 0. They will not be 0, but they will tend to 0. Now, for a perfect reflector, reflecting power will be equal to 1. Absorptive and transmitting power will be equal to 0. For a perfect transmitter, transmitting power will be equal to 1. Absorptive and reflecting power will be equal to 0. Now the last equation, a plus small a plus small r plus small t equals 1 can be written correctly as a lambda plus r lambda plus t lambda equals 1. Where lambda refers to a particular wavelength, we should specify wavelength because a body may absorb one wavelength and may reflect and transmit other wavelengths. Different bodies absorb different kinds of wavelength and transmits and reflects different other kinds of wavelengths. So that's all for today. Thank you.